So what we're looking for is the first thing we want to fill in with our variables. How fast did each drive? So what do you want to call? So how fast is under which column? Distance, speed, or time? Speed. And so Senta's speed we're going to call, what do you want to call that? S? Sure. And Jeff's we'll call G. Okay? From there we want to fill in another column. So what else do they tell me about this? So it says Senta and Jeff each drive 10 hours. They each have 10 hours. So could we put in the time? Yes. Okay. Now, they give us something about distance. They say all together they drive 1,900 kilometers. But is that specifically Senta's distance or Jeff's distance? No, that is specifically what? The total. So I can put that underneath here. That represents the total of Senta and Jeff. Now there's a reason why you need that formula. Once you have two boxes filled in, we're going to use the formula to get the third box. So I need to figure out, okay, what's the relationship between D, B, and T?
Multiply B by T, you're going to get D. So, for example, Senta, so you can go, like your equation times S10 plus G10.
Yep, you got it. So what I'm gonna get this last box of distance by multiplying the speed and the time together. So S times 10, how would we normally write that? And instead of S10, you'd write that as 10S. So we're multiplying those two together to get the third, always. So how to get this third? What would it be? 10G. Okay, so that gives me one full equation. Right? Which equation do we now know? The distance one, which is 10S plus 10G equals the total distance of 1,900. Now, we have one more formula we need to get, and it's probably going to come from where the variables are. We don't have a total. So they must have gave us some other information about speed. What did they tell us about speed? Okay, so Senta's was 4 kilometers per hour faster than Jeff's. So how would we make that equation if one's 4 who's faster? So Senta equals, if Senta's faster, Senta's was the same thing as is. So Senta's equals, if you're 4 faster, are you 4 times faster or are you just 4 more? 4 more. So it would be G plus 4 would be our two equations. Okay. So now we have two equations. Yeah, this one's set up nicely for what form? Substitution. So let's use substitution. We're going to replace S with G plus 4. So in that first equation, instead of writing S, I'm going to put in brackets G plus 4. I wrote a little big. And now what do I use? Now we can solve. Isn't it nice that our school is cooler today? I love it. 10G plus 40 plus another 10G is 1,900, or 20 Gs. Sounds like a lot of money. Okay, then want G by itself. Subtract 40. We have 20G equals 1860. And divide both by 20. 93. I'm going to go over here. such a G. Okay, and so I'm not done because I still need to what? S. So if G is 93, that looks like a weird G. 93 plus 4. So S is equal to 93 plus 4 or 97. So the last thing we should probably do is write a sentence, just like yesterday. So what did those represent? G was 97 and S was 93. Oops, no, G was 93, right?
Yeah.
Thanks, guys. So what's my sentence? So we're answering the question, how fast did they drive? So Santa drove 97 kilometers per hour, and Jeff drove 93 kilometers per hour. Sorry, I ran out of room. Got really messy. Okay. I don't love. Oh, is your say current or does it say overtaking? Yeah. Okay. There it is. This one. So yours overtaking is on the front page still. Yeah. You don't. This question I don't love, but we'll look at it really quickly. It's an airplane traveling 600 kilometers, left Vancouver, 13.5 hours. I can read. After a steamship had sailed, the plane overtook the ship in 1.5 hours. What was the speed of the steamship? A lot of information here. So let's start by just making a chart, filling in like the two situations. What are the two situations here? Let's just start making a chart, and then we'll go from there, and then we'll reread it. So what are the two things? Airplane and ship. Great. And at the top, yeah, we'll worry about that later. We're still gonna, I like to keep it always the same order, because then it's always the same every time, the chart. Distance equals speed times time. Okay. So in overtaking problems, just be very careful. So what does it mean to overtake? Like if I have my 3-year-old, I'm going to have a race with him, okay? I give him a head start. He's 3. Although at this point, he might actually be faster than me. So then, I give him a head start. He goes. Then I decide to go a little bit later. When do I overtake him? When you said it. When I pass him, okay? So if we start at the same time, if this is like if we actually watch the time of it, okay? So starts running. Now I start running a little bit later, but I'm going faster. The point I overtake him is the point I pass, right? So it's easier if you actually see this visually. Do you guys want to have 2 people come up here? Yes? No, I can't. I need 2 people. Okay. So, we got that covered. It is an airplane traveling at 600. Can we just throw that in the chart? Do we know the airplane speed? Yes. What are we looking for? I didn't answer that question yet. The speed of the ship. What do you want to call that? S, sure. S for speed of the steamship. Lots of S's there, so let's use one. Okay. Now, do we know about the time? What do we know about how long was the airplane in the air? So let's read this again. An airplane traveling 600 kilometers per hour. left Vancouver 13 and a half hours after the steamship did. So if the plane overtook the ship in 1.5 hours, so how long was the plane traveling? If it,
Okay, so maybe well, 1.5. Yeah, the air 1.5 and the boat would have been 13.
right. Okay, that's what it says. Wouldn't the boat be 15?
Oh, because it,
Okay, so let's talk about this. Would the plane be in the air for 1.5 hours? Yes. It said that the airplane left, the airplane left 13 and a half hours later than the steamship did. So the steamship had already been traveling for 13 and a half hours when the plane decided to finally leave. Did he overtake him at this point at 13 and a half hours? No. Then the plane is leaving, and after how long did it actually take to overtake? For the ship.
and the ship is still moving.
The ship was still moving. So 13 and a half plus 1.5. The ship was actually moving for 15 hours. Now this is a very easy one to solve. Because, can I easily get the distance of the plane? Yeah, using what? V times t. The distance equals v times t. So if d is equal to v times t, what is 600 times 1.5? 900. And what do we know about the two distances? They're the same. So we know 900 is going to equal to what? So if they're the same, that means 900 equals, how are these related? How is the distance, speed, and time of the ship related? Distance equals speed times time. So then 900 is equal to 15 times s.
No, technically all you have to do is subtract 15.
No, not subtract.
Divide.
Yes. Because they're times. Then all we have to do is divide. So s is 60. So therefore, the ship's speed was slow. Really slow. What I should have done is that I should have made a question. I should have made it that the airplane was traveling 10 times faster than the speed. I shouldn't have gave you the airplane speed. That would have been more interesting. If this was 10 times. Next time I'm going to do that.
Oh, for next year.
Yeah, for next year.
The next year.
Yeah. Okay, so the other two questions are actually in your workbooks that are on the back page. You can write them on there, or you can write them in your workbook. It's up to you. Same questions. Okay? So for those who want to look at their workbooks, we're actually not covering example 1 or example 2. In your workbooks, I want to do this. I'm trying to draw a picture here, but
You want a triangle?
I want to vomit on the triangle.
I know the triangle's circle. The vomit is yellow.
As a math teacher,
I love the triangle. Yeah, it's so easy.
it's great until you get to high school. And you have more complex equations that you actually need to manipulate. If you haven't practiced manipulating before, then it's like, I don't know. Why is physics so hard? Well, okay. So let's look at this. Which one is this one? Yeah, good. Okay, so another distance time. So let's When you see a distance equals speed times time type of question, you know you're going to have a chart. Okay? So let's read through the problem first. A student drove 1,245 kilometers from Edmonton to Vancouver in 16 and a half hours. This included a 1-hour stop in Golden and a 30-minute stop in Kamloops. Yeah, not bad. She averaged 100 kilometers per hour on the divided highways and 70 on the non-divided. How much time did she spend on the divided highways? Okay, so what are the two situations? No. What are we?
Divided and non-divided.
Divided versus non-divided. So the divided highway and non-divided. And I know that these are my two things because the question that they're asking us to find. They're saying, how much time did she spend on the divided highway? How much time did she spend on the divided highway? Okay, so the first thing we want to fill in is our variables. How do I know which column to look at to put my variables in? Yes, Caleb. How much time? So if we want to know how much time, the variables are going to go in time. So time undivided, we can call, should we just use X and Y, or do you want to do something different? You don't care? So divided is X time, non-divided is Y time. Is that good? Okay. Now, a student drove 1,245 kilometers from Edmonton to Vancouver in 16 and a half hours. Now, they gave me a distance and they gave me some information about time. Does that specifically talk about time on divided and time on non-divided? No, what do those represent? Totals. Do you agree that those are totals? So, a student drove from Edmonton, Vancouver, total distance, right? You can put that, if you don't have a spot for it, it goes in your, it's probably a total, it's gonna go at the bottom. Is the total time she drove 16 and a half hours? For actual driving time, because we have two situations. We have divided driving time and non-divided highway driving time. Yep. 15 hours total. Why is it 15? And 1 hour stop, and then another 30-minute means she actually drove for a total of 15 hours. Okay. Do I have one equation now? X plus Y is 15. We know one equation. The time on the divided plus the time on the undivided highway equals 15 hours. We know one equation. As soon as we know, right? This equals that. All right, what else do we know? Speed. What did she tell me about her speed? 100 on the divided and 75 on non-divided. Once you have two columns, you're going to use the formula for the third every time. So your first thing is you fill in your variables. What are you looking for? Then you're going to fill in some actual numbers in another column. And the third column, you always are going to use that formula. Okay? So what is the distance on divided going to be? 100 times X. And the distance on the non-divided? 75Y. And now do we have another equation? Yes. So the other equation is? Good. Now this equation lends itself to what type of form? Elimination or substitution? Well, it actually, yeah, it's pretty simple for both. We just did substitution, right? Yes, we did. So let's do elimination this time. What do you want to eliminate? X's or Y's? Okay, Y's it was. So if we're going to eliminate Y's, we're going to multiply the first equation by what? 75. 75x, 75y. You need your help with this one. 75 times, so 750 plus 325, 1,075? 1125, not even close. Added wrong. Okay, and then 100x plus 75y equals 1245. What are we going to do, add or subtract? Do the same sign? Subtract or switch your signs and then add. 75 minus 100. Negative 25x. 75 minus 75. 0 cancels out, equals 1125 minus 1245 is a negative 120, negative 1. Oh, well, that stinks. Our answer's going to be a decimal. That's okay. I think it's still a nice decimal. Divide both sides by negative 25. I know, when you get decimals, you start to second guess yourself, hey? Which equals what? 4.8. That's a nice decimal. 4.8. Okay, now what I need. Y. So the easiest way to find y is sub it into x plus y equals 15. So 4.8 plus y equals 15. Subtract 4.8 to both sides. That gives you 10.2. Okay. Now I should check my work, but I'm not going to save time today. Sentence though, therefore, what are they really looking for? What's the question? How much time she spent on divided. So if x was 4.8 and y is 10.2, which one do we want? 4.8. She spent 4.8 hours on the divided highway. Okay. Now, there's one unique case that's just a little bit different than all the rest. So all these ones have had the same format. Still similar format, but just a little bit different is example 4. Okay? And that's the current problems. Whenever you have current or like any form of current, whether you're an airplane flying against the wind and with the wind, or you're a boat going upstream and downstream, when there's a current that's going to be either pushing you or it's going to be slowing you down. Okay? Current problems are always set up a little bit different, but they're all going to be like this. Okay? So we're still dealing with distance equals speed times time. And the difference is the variables. Okay, and I'll show you what I mean. A small cruise boat took 3 hours to travel 36 kilometers down a river with the current. Now, if you're going with the current, what does it mean to go with the current? Is it helping you or hurting you? Yeah, it's helping. It's going to push you, right? It's pushing you.
Well, I mean, it depends on the
Okay? If you're going against the current, so you have your current plus you have your speed. If you're going against, this is my boat. Okay? Oh yeah, I forgot an S. Thanks. Oops. Oops. There you go. Okay, so if you're going against, if I'm going this way, or the current's going this way, but I want to go that way, it's going to slow you down, right? So you have your boat speed, and now your current is going to slow your speed in still water. Okay? So let's read through this again. A small cruise boat took 3 hours to travel 36 kilometers down a river with the current. On the return trip, it took 4 hours against. Does that make more sense? Does that make sense? It took you more time to go against than it takes you to go with. Find the speed of the current and the speed of the small boat in still water. Okay? So here's a problem. What they're looking for is the speed of the current and the speed of the boat in still water. Now, if I try and set those up as my two situations, do they give me information about just the current or just the still water? No. What are the two situations they describe to us? Against the current and with the current. I should actually probably go backwards on that, but whatever. With and against. So we're still looking for the speed of the current. So that's going to be a variable. The speed of the current, what do you want to call that? I can't speak today. Okay, current. What variable do you want to be the speed of the current? C. Sure, that's a great idea. We're going to let C be the speed of the current. And we're also looking for the speed of the small cruise boat in still water. What variable do you want to use for that?
W.
How about we use B for boat? Sure, you can do whatever you want. I'm going to use B. The speed of the boat in no current, in still water. So if there was no current at all, nothing's pushing me, nothing's holding me back, whatever force and speed I'm putting into it is what I go. Okay? So how does that relate? How do C and B relate to with the current? How does your speed with the current, how is that related to your speed in still water and your current speed, the speed of the current? So if you have your boat speed and you have your current speed, are they working together to push you?
Yeah.
Yes. So guess what that equals? C plus B. Or I'm going to write B plus C, the boat plus the current. Okay, so with the water, it's your speed in still water plus the currents pushing you a certain amount of speed. So together, that's your speed with the current. Against would be what? B minus C. Your speed in still water, the force that you're putting into it, what you would be in still water minus the current because you're going against it. So if your boat's going this way and the current's going that way, it's B minus C. Okay? So, let's fill in what we know now. What else do we know? Small cruise boat took 3 hours to travel 36 down a river with the current. So we know the time is for width is 3 and the distance is 36. Good. Against, the time was 4 and the distance was also, why is it 36 as well? Returning to the same spot. It's a return trip. So you go there and then you go back. So same distance. So we actually have two equations here. Do you see what they are? Okay, 36 equals B minus C times 4, or 4 times B minus C. Okay, distance is equal to is speed times time. So this is equal to the product of these two. It's one equation. What's the other equation? Times b plus c. So we can simplify each one of these. 36 equals 4b minus 4c. And 36 equals plus 3c. Okay, we're almost done. This is the very last question. Yeah. What do you want to do? Substitution, elimination, or graphical? We did it. How about you solve it? Okay? Okay, C. Okay, because the C's are already opposite signs. That's nice. So if I'm eliminating the C's, what would I have to multiply the first equation by? 3. Second equation we'd multiply by 4. Right? So, what is 36 times 3? 90, 108? Yay, right this time. Equals 12b minus 12c. 4 times 36, 20, 144. Equals 12b minus 12c. Oh, plus 12c. Now, are we adding or subtracting if we're eliminating the c's? Adding. They're opposite signs, so let's add this together. Add. Okay, because we want to eliminate c. 108 plus 144, 252 equals 24b, and then that's gone. Because we added, and the opposite signs make a 0. Divide by 24, 10.5? Okay, so 10.5 is B. Now we need to find C. Doesn't matter where you sub in. Where do you want to sub in? Like over here, or second one here? Okay, 36, the second one, equals 3 times 10.5 plus 3c. 3 times 10.5, 31.5. And then subtract 31.5. It's 4.5. Yes? I don't know. You guys are trusting me. That's funny. No, positive. And divide by 3 is 1.5, right? Yes? Okay, so what's our answer? Therefore, the boat's speed in still water is what? What is it? Nobody knows? No? That's 10.5 what? Kilometers per hour. The current speed is 1.5 kilometers per hour. Okay? So, let's circle the following. 5, 6, 7, 9. 4 questions to try. And you've got a lot of time. No? Oh. Darn.
All last week we had like 45 minutes to do homework. Wednesday we got like 10.
Yeah. Okay, please try at least one. 5, go try 5. 6, 7, and 9. So 4 questions.
What's our plan for the weekend? We talked about it last week.
Okay. Sure.